Juno spacecraft attempts to figure out mystery heating on Jupiter. The gas giant's upper atmosphere is significantly hotter than predicted by solar heating. Astronomers using ground-based and space telescopes were able to determine that winds are responsible for the anomalous heating of the upper atmosphere of Jupiter, which transfers heat from regions where auroras are raging to the equator of the giant. Jupiter is more than 5 times farther from the Sun than it is from Earth, and it receives much less solar radiation. Calculations show that the temperature in the upper atmosphere of Jupiter should remain below -70 degrees Celsius. However, real observations show something completely different, and scientists have long been looking for an energy source that heats the atmosphere above 400 degrees Celsius. This means that the gas giant's upper atmosphere is significantly hotter than predicted by solar heating. The processes that connect the planet's magnetosphere with the atmosphere and generate powerful auroras can act as a possible source of heat. In addition, ideas have been proposed for heating the outer layers of Jupiter due to internal gravitational or acoustic waves coming from the lower layers of the atmosphere. However, to date, observational data are not enough to reliably confirm any of these hypotheses. Using the Keck-2 telescope's infrared spectrometer, astronomers track the transfer of heat from the poles to the equator itself. Previously, it was not possible to notice this due to the low resolution. Now it has been brought to 2 degrees of latitude and altitude. These images show that the temperature at the poles of Jupiter is nowhere near as high as it would be if the hot air was trapped in these regions. When moving towards the equator, the temperature drops rather smoothly. Keck-2's observations were supported by the Japanese Hisaki probe. While in near-Earth orbit, he traced the magnetosphere of Jupiter at the same time periods in which the ground-based telescope recorded heat fluxes. At the same time, the Juno probe working near Jupiter filmed auroras collecting additional data on their dynamics. All this made it possible to draw up a detailed picture of the heating of the gas giant's atmosphere and confirm the hypothesis about the participation of auroras in this. The researchers determined that the temperature of the upper layers gradually decreased from the regions where auroras occur to the equator and were able to detect an unusual heated planetary scale wave in the atmosphere that was moving from the poles to the equator. They concluded that the observational data best describes a model in which meridional winds propagating towards the equator carry with them heat, which is a source of the aurora, and heat the upper atmosphere of Jupiter at many latitudes of the planet. At the same time, the intensity of heating depends on the state of the magnetosphere, which can contract due to the pressure of the solar wind and increase the precipitation of charged particles into the upper atmosphere of Jupiter near its poles.